In this video, we're going to be finding inverse functions. So we're going to do it 2 times. We have 2 examples here. In our first example, we have f of x equals 2 times the square root of x minus 3. So there's some pretty easy steps here to follow. So the first thing that we want to do is we want to take this f of x and we want to rewrite that as a y. So we have y equals 2 times the square root of x minus 3. Now the second thing we want to do is we want to take our y and our x and have them switch places so that we have x equals 2 times the square root of y minus 3. Then once we've done that, our third step is going to be to solve for y. So the first thing we're going to want to do here is divide both sides by 2 to get rid of that 2. And that's going to leave us with x over 2 equals the square root of y minus 3. Now we need to think, how do we get rid of a square root? What is the inverse operation of taking a square root? It's squaring it. So we're going to square both sides. That allows us to cancel out our square root and our square. And we'll distribute our 2. And that's going to give us x squared over 4 equals y minus 3. Then we're going to add 3 to both sides. And that's going to leave us with y equals x squared over 4 plus 3. And then our fourth and final step is to just rewrite it in inverse form. So the inverse function of f equals x squared over 4 plus 3. And we've written our inverse function. So our 4 steps are to first put the y instead of the f of x, second, switch the x and the y places, third, solve for y, and fourth, to rewrite it. So let's go ahead and let's do B together. Maybe let's not do it together. How about if you try it on your own? So try it on your own, so push pause, and then when you're done, push play, and let's see if you're right. So here we go. So our first step is to rewrite it as a y equals 2x to the third plus 1. Our second step should be to switch our x and our y. And our third step is going to be to get the y by itself. So that leaves us with x minus 1 equals 2y to the third. Then we'll divide both sides by 2. And that's going to give us x minus 1 over 2 equals y to the third. And then we have to think, how do we get rid of a cube? What is the inverse operation for cubing? And it's taking the cubed root. So we will take the cubed root of both sides. And that leaves us with y equals the cubed root of x minus 1 over the cubed root of 2. Well, let's back up for a second. So depending on what your teacher wants, you might be able to leave it as the cubed root of x minus 1 over 2 and then just to rewrite that. Okay, so that's an option. Or, let's come up here so we've got some more room, or you might need to have one more step where you rationalize that denominator. So if you have to rationalize that denominator, you will need to multiply, right? Multiply the numerator and the denominator by the cubed root of 2 times 2. because it's a cubed root, you need 3 2's total to bring out your 2. So that's why there's 2 2's in there. And so that would give us, let's not write it next to it, let's write it underneath. Okay, so that would give us y equals the cubed root of x minus 1 times the cubed root of 4 over 2, which would then give us the cubed root of 4 times x minus 1 over 2, which would be y equals the cubed root of 4x minus 4 over 2, which we would then rewrite as the inverse of f equals the cubed root of 4x minus 4 all over 2. So it really just depends here on what your teacher wants. Whether you finish it and can leave it like this, or if they want you to rationalize your denominator. Okay, these here are the same. The question is, do you need to rationalize or do you not need to rationalize? I find it's best to always ask your teacher to see what they want. But if you want the absolute simplest form, most correct answer, it's going to be the rationalized answer because we don't really like to leave things not rationalized.